So good evening, everyone, all the students who joined here. Thank you for joining one more session on pharmacoepidemiology. And as I discussed in the last class that we are going to be discussing on a randomized controlled trial, which we did not complete in the last class. So before going to start the randomized controlled trial, and it is going to be very exciting once again, like previous class, you're going to be do some calculations and try to interpret some results. That's what we're going to be do today. So before going and explaining about the randomized controlled trial, I would like to hear from you. I'm hoping that at least you've gone through and revised what we discussed in the last class, so that you can able to continue even in this class. Okay. So for that, I would like to ask any one of you to come forward and then recap what we discussed in the last class, so that it's going to be fresh for everyone, and maybe we can continue with the randomized control trial. Anyone? I can see there are around 58 participants joined here. Anyone? You can introduce yourself and then you can just give a recap like what we discussed. You can just mention the headings so that we can able to proceed further. Anyone? I'll be very happy for that if you can do that.
Yes, a great try.
In the last class, you were very active, so I was very happy. At least this class also, I'm expecting that. Anyone?
Oh, am I audible, sir?
Sanket, right?
Yes, sir.
Yeah, Sanket, you are audible.
Okay, so we looked at the pharmacoepidemiological studies, and specifically in that, we studied how it is a mix or an addition of pharmacology with epidemiology, and we're basically studying the use and the effects of drugs in a huge population and a number of people, basically. We looked at the different study designs. There was the descriptive and analytical, and within descriptive we had qualitative and survey, which was cross sectional, and qualitative was further divided into case series and case reports. Analytic was divided into experimental and observational, and experimental contained RCTs, randomized control tests, and observational contained cohort studies, case control studies, and cross sectional studies. So we looked at three questions which would help us in dividing these into various groups. Then we looked at the difference between case control, retrospective cohort, prospective cohort, and clinical trials. We also learned that prospective was looking forward and retrospective was looking backwards.
Exactly.
Yes.
That's good, Sanket. Thank you very much for that. Anyone can continue like what Sanket missed, or maybe if you would like to add any other points what we discussed in the last class. Maybe you can go further and then maybe explain what are the calculations we performed for the cohort and what calculations we performed for case control. Anyone? Thank you very much for that, Sanket. That's very good. Anyone would like to add any other points? So, and then we have discussed about all the study designs, especially the cohort study and case control study, if you remember. In the cohort study, what we calculated after conducting a cohort study, a prospective cohort study. In the prospective cohort study, we are going from the exposure to the outcome. If you remember, that's what we discussed. And we are going to be take two groups of people who are having the exposure and non-exposure. We are going to be follow them over a period of time, and then try to see how many people are getting the outcome in both the groups, in the exposure and non-exposure, right? And once we get this information, we have coded that information into A, B, C, D, A plus B, C plus D. So that's a coding we have given. And then we have calculated something to get more information to understand the association between the risk factor and outcome. So can anyone tell me what is that, what we calculated for cohort study? We have calculated something for a cohort study.
The relative risk.
The relative risk, exactly. So what is the formula for that relative risk we calculated for cohort study?
Incidence in exposure divided by incidence in non-exposure.
Okay, it is incidence. There are two types of incidences are there: incidence proportion and then incidence rate. So what we have used there in case of relative risk?
Incident proportion.
Incidence proportion, exactly. So incidence proportion in the exposure group divided by incidence proportion in the non-exposure group. That's what we did. And the simple formula I explained to you is A by A plus B divided by C by C plus D, right? Very simple formula. That's very good. And then we have discussed about the case control study, where we are conducting a retrospective study. We are taking the information on the outcome first. We are going to have two groups: the one group with the outcome, what we're expecting or what we need, and the second group is the people who are not having the outcome, right? And then we are going back and inquiring about the past history to understand about the exposure status. And there, once again, we are going to get four groups, like among the outcome positive, how many are having the exposure, how many are not having exposure. Among the outcome negative, how many are having the exposure and how many are not having the exposure, right? And once you get this information, we have coded all the data into A, B, C, D once again, and A plus C and B plus D. That's what we are having. And from there, from case control study, we have calculated one more important calculation. What is that?
Odds ratio.
Ratio.
Odds ratio, right? We calculated the odds ratio for case control study, the retrospective study design. And what's the formula for that?
A into D divided by B into C.
Yeah, it may be A by B divided by B by C, or we can write AD by BC, like cross multiplication, AD into AD divided by BC, we can have it, right? And if you want to understand the description of that formula, it's going to be odds of outcome in the exposure group divided by odds of outcome in the non-exposure group, right? So that's what we have discussed. And today maybe we can go and see what exactly there in the randomized control trial. RCTs are going to be very important. Whenever someone want to bring any molecule into the market, certainly they need to conduct some studies, and certainly they need to conduct the randomized control trials as part of maybe the phase 1, phase 2, phase 3 studies, right? So we are going to be see how exactly we are going to be conduct a randomized control trial, and what kind of calculations we are going to be performing the RCTs, randomized control trials. So just give me a second, I can share my screen, and then we can proceed further. Can you please confirm you are able to see my screen?
Yes, sir.
Yeah. So that's what we are going to be discussing. The experimental, we have only one example. That's a randomized control trial. And whenever you go and see any randomized control trial article, usually there are so many terminologies you're going to be see, and especially in the methodology section. And those terminologies are going to be very important. And you need to understand the meaning of each and every term, what they mention in the methodology. So what kind of terminologies usually we are going to be see, like multi-center study. Multi-center means the same protocol, the same study conducted in different centers. In India, maybe one center in Bangalore, or one center maybe in Mumbai, one center maybe in Delhi. So like that, they're going to be include multiple centers for the same study, and they're going to be right. It's a multi-center study. And sometimes it may be multi-country study as well. Multi-country study means same protocol, same study in different countries. They're going to be take different people from each country, and they're going to be conduct the study. So we can call it as a multi-country study. And the randomized is a very important term in case of RCTs, because that's the reason we are calling it as a randomized control trial. And we are going to be do something called randomization here. So we are having the people here, right? We are going to be take some people into the study, and all these people, we need to divide them into two groups, who are going to receive the standard therapy and who are going to receive the new treatment, right? And it is not that I'm selecting the people who are going to be here and who are going to be here. The computer is going to be decide which person is going to standard therapy and which person is going to intervention group. And that's what is called as a randomization. That means all the people to whom we are including into the study, they're divided into two or three groups randomly. We are randomly dividing all the people into two or more groups. That's what we can call it as a randomization. And randomization usually we are going to be performed by using the computerized technique. And that's what one of the important technique we are going to be follow in RCTs to avoid the selection bias. There are so many. There is a technique called selection bias. So to avoid the selection bias, we are going to be perform the randomization. Okay, there are so many types of randomizations are there. Maybe that you can learn in a different class. And usually we are going to be perform the double-blind study. Hope all of you know what is meant by a double-blind study, and where both the patient as well as the investigator don't know which medication they are taking. Either they are taking the interventional medication or they're taking the placebo. Both of them they don't know. That's what is called as a blinding. Mostly RCTs are going to be double blind in nature, wherever or whenever possible. Okay, so they're going to be give the placebo and they're going to be give the intervention, and both are going to be look same, taste same, everything is going to be same. So that's the reason both the patient as well as investigator don't know which medication they're taking. Okay, that's what is called as double blind. And sometimes in some cases we are going to be see even triple blind. So the triple blind, the meaning is both the patient, investigator, as well as the statistician who is performing all the calculations, analysis, even that person also don't know who is taking what. That's what is called as the triple blind. Very rarely we are going to be see that kind of study design. And the placebo control, it's very simple. So one group is going to be receive the intervention, the new treatment, and the other group is receiving the placebo, means that's what is called as the placebo control. The control group is receiving the placebo, so we can call it as a placebo control trial. And the parallel group or the crossover. The meaning is most of the studies are going to be parallel group, and sometimes it may be crossover. The parallel group, in the sense, we have divided all the patients into two groups right here, and we are giving here the standard therapy, and here we are giving the intervention, new treatment, and both the groups are going to be parallelly followed till the end of the study. Maybe for 5 years, we are going to be follow them parallelly. Both are going to be followed up together parallelly up to 5 years. Okay, and that's what is called as a parallel group study, parallel group randomized control trial. And the crossover, in the sense, initially first 2 years, this group is receiving the placebo and this group is going to be receive the new treatments. And after 2 years, there's a crossover here. This group is going to be come here and they're going to receive the intervention followed by maybe for another 2 years. And this group is going to be come here and they're going to receive the placebo for another 2 years. So what will happen here? Every patient is receiving both the placebo as well as intervention one or other time. Okay, so we can avoid some of the personal bias here by having both the intervention as well as placebo or control to the same patient at single point of time. Okay, so that's what is called as a crossover. After a certain period of time, placebo can go into the intervention group can come into the placebo group. That's what is called as the crossover. And usually we are going to be follow in rare cases the crossover type of study. And one more important terminology you are going to be identify in terms of statistical analysis. That's what is called as intention to treat analysis. ITA we can call it as intention to treat analysis. And I'll explain to you what exactly the meaning of this intention to treat analysis and how it is different from the per protocol analysis. There are two things usually we are going to be follow in case of RCTs, randomized control trials. It may be the per protocol analysis or it may be the intention to treat analysis. So we'll try to understand what exactly the meaning of this one in the next slide. So these are some of the important terminologies you need to understand in case if you're going through the randomized control trial. And usually they're going to be right in methodology. The study is a multi-center, randomized, double-blind, placebo-controlled, parallel group study. So what happened here? They have included all these terminologies and they mentioned the study design. So you can understand of the study design only when you understand the meaning of all these terms. That's why I'm explaining to you initially itself what is the meaning of each and every term, what they're using in the randomized control trial. And this is one of the important flowchart you're going to be observed in any type of randomized control trial, usually as a figure 1. If you go and take any randomized control trial article, usually the figure 1 is going to be looks like this, where they're going to be explain each and every aspect of the patient's population. How exactly it's going to be divided. There is an enrollment phase, allocation phase, follow-up phase, and analysis phase. And usually for any randomized control trial, what we are going to be happen is we are going to be assess all the patients, either they're eligible for our study or not, right? And for example, we have screened, we can call it as a screening. So we have screened 1,000, for example, and out of 1,000, 200 are not eligible based on our inclusion exclusion criteria, right? Every randomized control trial is going to have the protocol. In that protocol, they're going to be clearly mentioned who will be included and who will be excluded. Based on that criteria, they're going to be exclude the patients who are not coming into the inclusion criteria. Okay. So for example, 200 are excluded, and they have mentioned all the reasons why they have excluded the 200 patients. And the remaining, we have 800 patients. Out of 1,000, we have excluded 200, and remaining we are having 800 patients, right? And all these 800 patients, we are dividing them into two groups by using the randomization. And one group is going to be receiving the intervention, and other group is receiving the placebo. Here they mention intervention, just imagine that it's going to be the placebo. So one group is receiving 400 receiving intervention and 400 receiving the placebo. And after receiving, we are going to be follow them over a period of time. And finally, we are going to be see how many are there till the end of the study. And then we are going to be perform the analysis. This one is a follow-up phase. And here we are going to be do the analysis. Let us imagine it is not that we have taken the 400. All the 400 will be there till the end of the study, because the study is going to be conducted for another 5 years. And we cannot expect that all the 400 will be there with us for all the 5 years. Some may drop from the study because of various reasons. They may drop from the study. Some people may die, or some people may change address. Some people, they don't want to continue further. There may be so many reasons, dropouts we can expect. Let us imagine out of 400, there are 10 dropouts here. That means a total of 390 are available till the end of the study. Okay, so out of 400, 10 dropouts were there, and we need to mention certainly what is the reason behind dropping of all these 10 patients, and finally how many are there for the analysis. And here also same, in the placebo group out of 400, let us imagine here we have 20 people who lost to follow, and remaining we have 380 people. Okay, so now just tell me, if you want to do the analysis of this randomized controlled trial, so which number you are going to be take for the analysis purpose? Either you are going to be take this 390 and 380 who are there till the end of the study, or you are going to be take this 400 and 400 to whom we randomized initially and given the therapy. So which number you are going to be take usually for analysis? Anyone?
400.
So you're going to be take the 400 and 400, or you're going to be take this who are there till the end of the study, 390 and 380. Which one we are going to be take usually?
400.
400. Okay. So if you take the 400 and 400 in both the groups for the analysis purpose, and that's what we are going to be call it as a intention to treat analysis. Okay, that means we have taken all the people to given at least one medication. Why? Because during the randomization itself, the first medication we are going to be given to the patient. That means all these 400 patients in both the groups received at least one therapy, one medication. Okay, so we are going to include all these 400 and 400 patients into the analysis. That's what we are going to be call it as a intention to treat analysis. But usually what people will think is, because we are going to be take this 380 and 390. Why? Because these are the 390 and 380 patients who are there till the end of the study. And we got to know each and every information about this 390 and 380. Not for the remaining patients, because they lost to follow. In between, they lost to follow. And we don't know much information about these people. So we will eliminate this one. And we will take only this 390 and 380. Some people may think about that, right? So whenever they take this 390 and 380 for the analysis purpose, and that's what we are going to be call it as a per protocol analysis. There are two types of analysis. Per protocol analysis, that means you are going to be take the people who are there till the end of the study. Or if you take this 400 and 400 to whom you randomized initially, we can call it as a intention to treat analysis. And nowadays, most of the randomized control trials, they're going to be take this intention to treat analysis in comparison with a per protocol analysis. Why? Because they don't want to lose any patients for the analysis purpose. And that's the reason usually they're going to be take this kind of people for the analysis purpose. And we can call it as a intention to treat analysis. Okay, hope it is clear for you. And this kind of flowchart, if you see in a randomized control trial article, we are going to be call that one as a consort flowchart, CONSORT. There's a full form for this one, consort. It is a consolidated standards of reporting trials. Consort is a consolidated standards of reporting trials. And these are the standard guidelines which are available for conducting any randomized control trial. In that, they have given this flowchart as an example, and that's what everyone needs to follow with little bit modifications. So that's the reason we are going to be call it as a consort flowchart. Okay, just remember this one for a randomized control trial. So now we will go and discuss one of the case study for this randomized control trial, and then we can perform some calculations. Just imagine that we are conducting a study by having this PICO, PICO. P is a patient's, I is a intervention, and C is a control, and O is outcome what we're expecting. Okay. So imagine that we are taking the patients who are having the type 2 diabetes mellitus and also who are having established cardiovascular diseases. So the patients to whom we are taking, they're having two important conditions. One is a diabetes, another one is a cardiovascular disease already existing. Okay. And the intervention what we are going to be give is we are giving the empagliflozin as an intervention, one of the SGLT2 inhibitor for diabetes. And we are going to give any one of this dose. Either we are giving 10 mg or 25 mg of empagliflozin as an intervention. As a control, we are giving the placebo, which is very similar to the empagliflozin, and then we are going to be conduct the double-blind study. And the outcome, what we're expecting here, it is the death from cardiovascular causes, non-fatal myocardial infarction, and non-fatal stroke. These are all the fatal outcomes. The person may die because of the cardiovascular problem, or the person may get myocardial infarction, which is non-fatal. Non-fatal means it is not causing any death, or the person may get non-fatal stroke. And if the person gets any one of this outcome, we can say the person got the primary outcome. So the primary outcome of this study is the person can get any one of this outcome after receiving empagliflozin or placebo. So here our aim or hypothesis is by giving the empagliflozin, we would like to reduce these outcomes when the patient is having this type 2 diabetes and already cardiovascular diseases in comparison with the placebo. Okay, so we are trying to reduce these outcomes by giving the empagliflozin. Just imagine we are reducing these outcomes by giving the empagliflozin in comparison with the placebo. Okay, so the person no need to get all the three outcomes. I'm repeating it once again. The person no need to get all the three outcomes. If the person gets any one of this outcome also, we can say the person got the primary outcome. Okay, and these are the results we are having. The primary outcome occurred in 490 patients out of 4,687 patients to whom we have taken into the group, that is intervention group. And if you calculate the percentage, it is going to be 10.5 percentage. Okay, so 490 got the primary outcome, that is any one of the previous outcomes what I shown you in the previous slide. And out of 4,687 patients, that is around 10.5% of people got the outcome, and that's what we're going to be call it as a absolute risk. Okay, and we have one more group, that is a placebo group. And in the placebo group, a total we are having 2,333 patients, and out of that we have 282 patients who got the primary outcome, that is equal to around 12.1 percentage, and we can call it as a reference risk. It's very simple information what we're having here. Total how many we have taken in both the groups, empagliflozin and placebo. Out of these two groups, how many got the primary outcome? The primary outcome is any one of this outcome, death from cardiovascular cause, non-fatal myocardial infarction, or non-fatal stroke. The person gets any one of this outcome, we can call it as a primary outcome. Okay, so 490 got in the empagliflozin group, that's equal to around 10.5 percentage. 282 got the primary outcome in the placebo group, that is equal to 12.1 percentage. So by using this information, can you please calculate the relative risk, what we discussed in the last class? Remember the formula and use all the numbers which are there in the slide, and then try to calculate the relative risk. I would like to see who will calculate first, who can trace out the relative risk value. As you remember, the formula for relative risk is A by A plus B divided by C plus D. And in this slide, we are having all the values to who means what we are going to be used in the formula. It is very easy to calculate. Anyone? Relative risk, because it's a prospective study, we can calculate the relative risk. And you have all the numbers here, which can be incorporated into the formula. Anyone? It is not going to take this much time, I'm sure. I would like to hear from you to proceed further. Sanket?
So I've got 0.86.
0.86. That's good, Sanket. So can you please explain how you calculated that relative risk?
So I took A as 490 and B as 282. Sorry, and
282 is
C as 282.
yeah.
And A plus B is 4687 and C plus D
Exactly.
is 2333.
Exactly. So that's what we are going to be have the values. So this is the A, people who got the outcome in the treatment group, divided by total number of people A plus B in the treatment group, exposure group. Okay. And this is going to be C, the people who got the outcome in the non-exposure group, divided by total number of people in the non-exposure group, that is C plus D. A by A plus B, C by C plus D. If you do that, how much you got?
0.86.
0.86. That's good. So let us see how much we are having here. And the relative risk formula, what we already discussed. What we are doing exactly is it is a risk of outcome in the treatment group divided by risk of outcome in the control group. Very simple formula. How much risk is there in the treatment group divided by how much risk is there in the control group. And if you incorporate all the values, we are going to have 0.105 divided by 0.121. This is A by A plus B. This is C by C plus D. And we got 0.86. Okay. So what's the conclusion here? We got the 0.86 as a relative risk. Can anyone tell me what is the interpretation? What is the conclusion? And we are not calculating here the 95% confidence interval. I'll give you the 95% confidence interval, the imaginary values. So 0.86 is a relative risk. Okay. Imagine that we have 0.70 as 0.70 as lower limit and 0.95 as upper limit. Imagine that we have a confidence interval here. Lower limit is 0.70, upper limit is 0.95. So imagine that and tell me what is the conclusion from this calculation.
The outcomes are clinically significant.
The outcome is significant, that's good. And 0.86 is a less than 1. So we can say the chance of getting the outcome is less. In the first group, what is the first group here? The treatment group. So the chance of getting the primary outcome, that is cardiovascular death, myocardial infarction, stroke, the chance of getting this outcome is less in treatment group, that is empirical fluorescein group, compared to the placebo group. Okay. Why I'm saying less? Because the value what we got here is less than 1. Okay. Then we can say it is less. And also the confidence interval what we are having here, this one is a less than 1. And both the lower limit and upper limit what I mentioned, they are also less than 1. So we can say that the value what we got here, it is a statistically significant. Is that clear to everyone? And how much less it is? I mentioned there's a less chance of getting the outcome, but we need to quantify how much less compared to the placebo. How we are going to be quantify that? How much less? I think I explained very clearly in the last class.
1 minus 0.86.
Yeah, 1 minus
0.86. That's
1
around
minus 0.86. And how much you are getting?
0.15.
0.14, right?
1.
We can say that people who received empirical fluorescein, they're having 0.14 times less chance of getting the outcome compared to the people who are receiving the placebo. Okay. If you're not convenient to say 0.14 times, because it is not 1 time, 2 times, it is 0.14 times, we can convert that into percentage and we can say that the people who are receiving empirical fluorescein, they're having 14%, 0.14 you are converting into percentage, the 14% less chance of getting the outcome compared to the people who are receiving placebo. Okay, so how we are quantifying that, how much less, how much more is what we are doing here. Simply we are subtracting the 1 minus relative risk what we got, right? So whenever you subtract this the relative risk from 1, that's what we are going to be call it as a relative risk reduction. So if you want to conclude what are the subtraction you are doing, that is 1 minus relative risk, there is a formula for that. There's a name for that. We can call it as a relative risk reduction, RRR. So the RRR here, it is a 1 minus 0.86. That's going to be 0.14. If you convert into percentage, we can call it as a 14%. So there's a 14% less chance of getting the outcome, primary outcome, for the people who are receiving empirical flowcin compared to placebo. Okay, that's the final conclusion what we are going to be getting out of this calculation of relative risk and relative risk reduction. It's very simple. What are the 1 minus you are doing? We can call it as a relative risk reduction. Okay, so you just note down these numbers, these two numbers, before going for further calculation. Just note down these numbers. The one is 0.105, right? The first one. The 0.105 is a risk of outcome in the treatment group, and 0.121 is a risk of outcome in the control group, right? We are already having that information. Just note down these numbers, then we can go for further calculation. Hope you understand till now how to calculate the relative risk and relative risk reduction. They are very, very simple formulas. You can just calculate easily once you have all the numbers. So now we are going to be calculate something called absolute risk reduction. Previously, we have seen the relative risk reduction. Relatively, how much reduction is there? And absolutely, how much reduction is there? That's what is called as the absolute risk reduction, ARR. So how we are going to be calculate that is, it is a risk of outcome in the control group first minus risk of outcome in the treatment group. So once again, risk of outcome in the control group minus risk of outcome in the treatment group. And that's what we are going to be call it as absolute risk reduction, or sometimes we can call it as a absolute risk difference also, ARD. Can someone tell me what is the value here? Absolute risk reduction. We have taken the values from here. So this is the risk of outcome in the treatment group, and this is the risk of outcome in the control group. Just take these values and apply in this formula. Risk of outcome in the control group minus risk of outcome in the treatment group. How much it is? Use only the numbers. Yeah, use only the numbers. Don't use the percentages for calculation. Use only the numbers. How much it is?
0.016.
0.016. Okay, let us see. 0.016. So 0.121 minus 0.105. If you make it, we are going to get 0.016. So the absolute difference, the accurate difference between the treatment group and the control group is only 0.016. If you convert into percentage, it's going to be 1.6%. Okay, so the exact difference, the absolute difference between exposure group and the non-exposure group is only 1.6%. What we got here, 14% is relatively. So relatively means when you think that the placebo is not at all having any effect, we can say that intervention is having around 14%. So relatively 14% reduction in the risk. But absolutely speaking, accurately speaking, the difference between treatment group and the control group is only 1.6%. So the 1.6% what we got here, it is just nothing but the difference between these two percentages. As we know already, 10.5% risk is there in the treatment group, and 12.1% risk is there in the control group. The exact difference between these two percentages, it is only 1.6%. Okay, so what are the 1.6% exact differences there between these two groups? We can call it as a absolute risk reduction or absolute risk difference. Okay, so just remember these two things. This one is a relative risk reduction. Relatively, this much reduction is there, and this one is a absolute risk reduction. Accurately, this much difference is there between the treatment group and control group. Only 1.6%. Okay, so if you are a researcher, if you are a manufacturer of any medication, and you are doing a randomized control trial, and when you want to go for a publication, so which one you would like to keep in your manuscript or in your article? You want to keep the relative risk reduction, or you want to keep the absolute risk reduction? Anyone? if you are a researcher, you would like to bring a molecule into the market, you did a randomized control trial, which one you are going to be represent in your article? Say something, no problem. Any option is fine. Relative risk reduction or absolute risk reduction? Which one you would like to keep in the article?
I would go for relative risk because it's a greater amount and
Exactly.
it would,
So, yeah, being the manufacturer, no, always we would like to show there is a more reduction is there because the outcome is a death, right? We want to show that by taking that medication, our medication, the reduction in the death is going to be very high. We want to show that always. So that's why usually people prefer that keeping the relative risk reduction that's around 14%, and they don't mention about absolute reduction that is a 1.6%. So being a pharmacy person, being a Pharm D or pharmacy practice person who is evaluating the articles regularly, so we should not confuse by seeing only the relative risk reduction. You know how to calculate the absolute risk reduction. So you need to see how much accurate difference is there between the placebo and empirical fluorescein. So what is happening here, by giving the empirical fluorescein, there is only 1.6% of increase in the reduction. The placebo also reducing something, and empirical fluorescein also reducing something, but the difference between placebo and empirical fluorescein is only 1.6%, very minimum percentage. Only 1.6% reduction is there in the primary outcome. Okay, so for that understanding, we need to calculate the absolute risk reduction from these values. And from this absolute risk reduction, we are going to be calculating something called number needed to treat, NNT, I can say. And it's very simple calculation. It is just an inverse of absolute risk reduction, 1 by ARR. So always we are going to be take the original values only for calculation. Number needed to treat here, it is a 1 by 0.016. It is 1 by absolute risk reduction. How much it is?
62.5.
62.5, maybe we can say it as a 63. Okay, 1 by 0.016, 63. Okay, it's somewhat difficult to interpret the 63. Just keep your ears open and then listen what I'm going to say. The interpretation of NNT, number needed to treat. Okay, the meaning of the 63 here it is, you need to treat a minimum of 63 people with empirical fluorescein to prevent one person getting the primary outcome. What's the primary outcome? Death or myocardial infarction or stroke. Okay, to prevent one person getting this any one of this outcome, to prevent that, we need to treat a minimum of 63 people so that we can prevent one person getting this outcome. And remaining people may or may not going to be get. Okay, we are sure that if you treat 63 people, in that we can prevent of getting these outcomes to one person. Okay, so in this case, if you want to say that your drug is more efficacious, okay, your drug is more efficacious in preventing the primary outcome, so the number should be less or more. I'm asking the question, if you want to say that your drug is more efficacious, the NNT number in this case, I'm asking only in this case, here the case is to prevent the primary outcome, to prevent the death or to prevent the myocardial infarction or the stroke. Okay, to say that your drug is more efficacious, you need to get the more number or you need to get the less number of NNT.
in this case, less.
Exactly. So in this case, it should be less. I'm giving the example, by treating 20, if you prevent the one person getting the outcome, that's going to be much better than treating 63 and preventing one person, right? So whenever, in this case, in these kind of cases, whenever the NNT is less, we can say that the drug is more efficacious. Just imagine that, remember that. So we are going to be calculating the NNT to understand that how much efficacious the drug is in comparison with the placebo. Okay, that's the reason always we're going to be have the risk benefit analysis. For the risk benefit analysis, usually we are going to be calculate the NNT, number needed to treat. I'm sure, I think none of you gone through these kind of calculations during your pharmacoepidemiology classes. If you have gone through, it's very good to go through all those things. So if you did not gone through all those things during your classes, regular classes, just remember and try to implement these things when you go and read the article. You need to calculate the NNT to understand better about the medication, how much efficacious it is. It is going to be depending upon the number what we are going to be get for NNT, number needed to treat. So usually we need to get the lesson number so that we can say it is more efficacious. Okay. So whenever you're conducting any randomized control trial, we should not always focus on the efficacy only. We need to understand about the safety of the medication also, right? So here, the clinical significance can be determined by some extent by looking after the NNTs, but also by weighing about the NNTs against the harms or adverse effects. So for that reason, we are going to be calculating something called NNH. So NNH is the number needed to treat. Can you please unmute yourself? I think someone. Uh, can you please mute? Sorry. So don't unmute so that it will be very clear. So we are going to be calculating the NNH, so number needed to harm. Okay. So we have calculated the number needed to treat for the efficacy outcome, right? When you come to the safety outcome or adverse outcome, we need to calculate the NNH, number needed to harm. So for this, I'm going to give you one case study here. And here the outcome what we're expecting is a genital infection. So the genital infection is outcome here. And these are the results we are having. Empirical fluorescent group, out of the total number what I mentioned in the previous slide, out of that number, 301 got the genital infection. That is equal to around 6.4%. Out of the placebo group, I think we are having 2,333 as a placebo group. Out of that, 42 got the genital infection. That is equal to 1.8%. Okay. So we are getting 1.8% for the placebo group and 6.4% for the empirical fluorescent group. Okay. So the total numbers are same. Whatever I have given here, the total numbers, they are same here. Like these are the total numbers out of 4687 in the empirical fluorescent group and out of 2333 in the placebo group. And out of these two numbers, what I mentioned, we are having 301 for the genital infection in the empirical fluorescent group and 42 in the placebo group. That's about the genital infection. Okay. So by taking these numbers, you know the total number, you know how many people got the outcome. That is a genital infection. And can you please calculate all the things, whatever we calculated till now? So I want from you the relative risk reduction, absolute risk reduction, and number needed to harm. And why I'm calling it as a harm? Because the outcome what we are having here, it is a adverse outcome, genital infection after taking the medication. Okay. So can you please calculate and then tell me what are the numbers? What is a relative risk and what is a relative risk reduction? What is absolute risk reduction? And then what is NNH? I would like to hear from you all these values. So we already calculated all of them. You just need to calculate once again by taking these numbers. So any quick result from anyone? It's very easy, nothing difficult.
Relative risk 3.56.
Okay, relative risk 3.56. Okay. And the relative risk reduction?
2.5.
2.56. Of course, we are going to be do -1. And the absolute risk reduction?
4.6.
4.6. Okay. 4.6 in a percentage or 4.6 is a number?
Number.
Okay. Okay. And NNH? NNH. It is just, Easy. 1 by ARR.
0.217.
0.214.
217.
Okay, let us see. So we're having relative risk of 3.56, that is equal to 0.064 divided by 0.018. We are having 3.56. So if you do -1, we are going to be have 2.56. -1, we are going to be have 2.56. So we can say that 2.56 is a relative risk. Imagine that we are having both the lower limit and upper limit also more than 1. We can say that the value is significant. Okay. We can say that people who are receiving empirical flows in having 2.56 times more chance of getting the genital infection compared to the placebo group. Okay. And don't confuse, sometimes maybe in some article, I'm saying here 2.56 times after subtracting 1, right? In some article, they will directly say 3.56 times. Don't confuse, okay? Sometimes they'll say 3.56, but accurately speaking, exactly speaking, it is not 3.56, it is only 2.56. Don't confuse and don't understand that I taught you something wrong, okay? Accurately speaking, it is only 2.56, not the 3.56. And the absolute risk reduction, what we got is 0.046. 0.046 is a number. And if you convert into percentage, then it's going to be 4.6 percentage. Okay, the number is going to be only 0.046. That is equal to 0.018 minus 0.064. And 1 by 0.046, if you do, we are going to be get 22. Okay, 1 by 0.046, we are going to get 22. That is NNH, number needed to harm. Okay. So the exact difference between, so we got to know what is a relative risk and what is a relative risk reduction, how much reduction is there relatively. And the absolute risk difference, what we are having between these two is only 4.6 percentage. So the exact difference between this 1.8 percentage and 6.4 percentage is how much it is? It is a 4.6 percentage. Actually, here we need to get minus value. No need to bother about minus or plus. We can take only the value here, 0.046. You can convert that into percentage. We are going to be get 4.6 percentage. The meaning here it is the exact difference between the empirical closing group and the placebo group. It is only 4.6 percentage. Okay, and the NNH number needed to harm, that is equal to 22. So the interpretation of NNH here it is, we need to treat a minimum of 22 people to get one person with genital infection. So here it is a getting, not preventing. In the previous case, NNT, it is preventing, because by giving the empirical close-in, we want to prevent the primary outcome, right? But here what is happening, by giving the empirical close-in, the person is getting the mycotic infection, genital mycotic infection, right? Here it's a getting and there it's a preventing. So if you treat 22 people with empirical close-in, in that one person is going to be get genital infection. Imagine if you treat 22, in that one person is going to be get the genital infection, it is an adverse outcome. So now, if you want to say that your drug is more safer, if you want to say that your drug is more safer, this number of NNH should be less or more.
It should be
The
more.
number
It should be more.
the number of NNH should be more, then we can say our drug is more safer. Why? Because if you treat 22, one person getting the infection, if you treat 60, one person getting the infection, of course, 60 is much better than the 22. Be here in the case of NNH, because the person is getting the adverse outcome, so the number should be more, then we can say our drug is more safer. Okay, so for NNT, the number should be less, we can say it is efficacious. And for the NNH, the number should be more, we can say it is a more safer. Okay, so these are all the calculations we usually we need to perform. These are all the things may not be there in an article, randomized controlled article. So because you know how to calculate, you can calculate all these things and try to understand more about the medication. Then you can take the appropriate decision, or you can come to the conclusion. Coming to the advantages of disadvantages of randomized controlled trial, it is very unbiased distribution of confounders will be there, because we are doing randomization here. Blinding is going to be possible most of the times. That's the reason randomized controlled trials are going to be the gold standard in nature. And randomization is going to be facilitate most of the statistical analysis, whatever we are going to be performed. And the disadvantages are going to be like it's going to be more expensive than any other study design what we discussed previously, because it's going to be consume more time and money and energy, everything. And sometimes we can understand some of the volunteer bias will be there. So many volunteers will be involved in the study. And if anyone do any mistake, there may be some biases in the results. Okay, some volunteer bias we can expect, and sometimes ethically problematic. It is not that very easy to get any ethics committee permission for randomized control trial, because here we are giving the intervention. It is not that we are just observing the patient, we are giving some intervention. We are giving some extra medication to the patient. It's a testing medication. So something can happen to the patient later after taking this medication. So because of these reasons, taking the ethics committee permission, getting the ethics committee permission is going to be sometimes problematic, especially in case of the randomized control trials. So now we are coming to this particular article, which is published in New England Journal of Medicine, I think somewhere around 2015. Here, the same what we discussed, that is empirical frozen cardiovascular outcomes and mortality in type 2 diabetes mellitus. Okay, that's the title of the study. And the outcome what we're expecting here is a primary outcome is going to be same, what we discussed. It may be death from cardiovascular causes, non-fatal myocardial infarction, or non-fatal stroke. Okay. And you can see here, you can imagine here in empirical frozen, sorry, in placebo, we have 2,333 people overall. In empirical frozen, we are having 4,687. And out of this placebo, 282 got the primary outcome, any one of this outcome, that is equal to 12.1 percentage. And in the empirical frozen, 490 got the primary outcome, that is equal to 10.5 percentage. So by using this 282 and 490, we have already calculated the relative risk, and then we got to know how much outcome is there. And now what we are going to do in this calculation is, in this article, they did not calculate the relative risk, they calculated something called hazard ratio. The hazard ratio is very similar to relative risk, but they're not going to use these numbers like 282 and 490. They're not using these numbers. They're using something called incidence rate. So for this one, we have used incidence proportion, right? We are taking the proportion here. And for calculating the hazard ratio, they're taking the incidence rate. So they have already calculated how much rate is there in the placebo and how much rate is there in the empirical frozen. So the rate per 1,000 patient years, it is equal to 37.4, and rate per 1,000 patient years in placebo is equal to 43.9. Okay, so that's what is called as a incidence rate, which they have already calculated. Okay, so now what we're going to do for hazard ratio formula, it's very simple. That is a incidence rate in the empirical frozen group or the exposure group divided by incidence rate in the placebo group, okay, or non-exposure group. So 37.4 divided by 43.9, if you make, we are going to be getting this 0.86. So 0.86 is a hazard ratio here, incidence rate in the exposure group divided by incidence rate in the non-exposure group. It's very simple formula, and 0.86 we got, and along with that we are having the confidence interval 0.74 and 0.99. So can someone give me what's the conclusion from this one, from this hazard ratio and the confidence interval? As I mentioned initially, the interpretation is same. Hazard ratio, odds ratio, relative risk, whatever you are going to be calculated for different study designs, the interpretation is going to be same. Can someone conclude for me? What's the conclusion? What's the interpretation here? It's very easy now for you. Anyone? Anyone, please? Because I'll get some satisfaction that you got the understanding. I can explain this, but I would like to hear from you. Even if it is wrong, there is no issue.
The patients that took empagliflozin have 1 minus 0.86, which is 0.14 times lesser chance of showing the primary outcome compared to those patients that were given the placebo.
Exactly. Sanket, right? Or anyone?
Yes, sir.
Yeah, that's good, Sanket. Thank you for that. So first of all, we can see 0.86. It is less than 1. We can say less chance of getting the outcome. For whom? People who are receiving the empirical frozen. Why it is only empirical frozen means? Because we have taken this one as a numerator. This one we have taken first, divided by this one, right? So all the result we need to apply for the empirical frozen only. Let them give in table any one first. They will give the empirical frozen first, or maybe the placebo first, no issue. But what we are taking in the numerator, for that we need to apply the conclusion. Okay. So less chance of getting the outcome for the empirical frozen compared to placebo. And how much less? 1 minus 0.86. We're going to get 0.14. So 0.14 times we can say, or we can say it is a 14% less chance of getting the primary outcome for the empirical fluorescent group compared to the placebo group. It's very simple. And we are giving that conclusion because the value what we are having here found to be statistically significant. Why it is significant? The value is less than 1, lower limit also less than 1, and upper limit also less than 1, right? So because the value is significant, we are concluding that 14% less chance of getting the primary outcome for empirical fluorescence. That's very good. And at the same time, we are having the p-value also here. The p-value, what we found here is 0.04. It is less than 0.05. Even it is giving the information that the value what we got here is statistically significant. Okay. And we are having something called secondary outcome here. It is almost like primary outcome only. Death from cardiovascular causes, non-fatal myocardial infarction, non-fatal stroke. Along with that, we have one more outcome, that is a hospitalization for unstable angina. So there is one more outcome they have added, and they made it as a secondary outcome. And they have all these values here. And finally, they got this value, this number. 0.89 is a hazard ratio, 0.78 is a lower limit, and 1.01 is a upper limit. So can anyone tell me what's the conclusion from this one? What is the conclusion for the secondary outcome? Anyone?
In this case, the effect of empagliflozin is, unclear because the upper limit is greater than 1.
Exactly. So unclear in the sense we can say it is not significant. And we say that there is no association identified for the secondary outcome. Why? Because we cannot say that 0.89 minus 1, we are going to get 0.11, that 11%. We cannot say that 11% reduction. Why? Because the value found to be not significant. Why it is not significant? The lower limit is less than 1 and upper limit is more than 1. So we can say it is not significant. So we cannot give that 11% reduction in the conclusion. And we can say that there is no association. Whenever something is not significant, usually we are going to be say there is no association for the secondary outcome in between placebo and empirical fluorescence. And at the same time, you can see the p-value here. The p-value found to be more than 0.05. It is also showing that the value what we got here is not statistically significant. Okay. And now they have some more calculations. All the primary outcomes they have divided into 3 types, and they have assessed individually. So we'll quickly go and see one by one. And here the patients are getting some death, right? In the death, they have divided into 2 categories: death from any cause or death from cardiovascular causes. Okay, either the person is dying because of any reason, or the person is dying from cardiovascular causes. And for that, they have given all these values once again, and we can go and see directly the hazard ratio. So death for any cause, the hazard ratio is 0.68, lower limit is 0.57, and upper limit is 0.82. So what's the conclusion from this one? Anyone apart from Sanket? I would like to hear from you. Any girls?
The
What's the
outcome is
conclusion?
negative, and it is significant, but the outcome is negative.
Can you repeat it once again, please?
As both the upper limit and lower limit are less than 1, it indicates that there is a negative outcome, and it is statistically significant.
Negative in the sense it is reducing, right? The outcome, what are the outcome we are having here?
Yes.
Death from any cause. Because it is less than 1, it is reducing. Reducing for what? Empirical fluorescence. So we can conclude it clearly. 1 minus 0.68 if you make, how much we are going to get? 1 minus 0.68?
32.
Yeah, I think no need to think that much. 1
I mean,
minus
0.32, sir.
yeah, 0.68 is a 0.32, right? 0.32, we can convert into percentage, 32%, right? So because it is less than 1 and both the values are giving less than 1, because we know it is significant, we can give that conclusion. People who are receiving empirical fluorescence having 32% of less chance of getting the death from any cause. And by seeing the p-value also, p-value is less than 0.001, we can clearly understand the value found to be statistically significant. Once again, okay. And what about this one? Death from cardiovascular causes. And once again, they have given the hazard ratio along with the confidence interval. Anyone? What's the conclusion and interpretation from this one?
There is 38% lesser chance from cardiovascular diseases.
Exactly. So people who are receiving empagliflozin having 38% of less chance of getting the cardiovascular causes, means death because of cardiovascular causes, compared to the placebo. So why we are giving that conclusion? This is less than 1, and also it's found to be statistically significant because both the values are less than 1, and also p-value is less than 0.05. So we can certainly say that people who are receiving empagliflozin having 38% of less chance of getting the death from cardiovascular causes in comparison with the placebo. And finally, we are having this hospitalization for heart failure, right? And for that, we are having this hazard ratio outcome. 0.65 is a hazard ratio, and 0.50 is a lower limit, and 0.85 is a upper limit. Okay. So what's the conclusion from this one? Anyone? And the p-value is 0.002.
Same, sir. That is 35% lesser chance of getting hospitalized for heart failure. And it is statistically significant because it is p-value is less than 0.005 anyway.
Okay, exactly. So what we're going to get here, it is people who are receiving empagliflozin, they're having 35% less chance of getting the hospitalization for heart failure in comparison with the placebo, because the value found to be less than 1, and this value is also less than 1, and this value is less than 0.05, right? So it is statistically significant, and we can give the conclusion of 35% less chance of getting the hospitalization for heart failure. Okay. So till now, you learn many things, right? How to calculate odds ratio, relative risk, hazard ratio, 95% confidence interval, and how to interpret all the results. Everything is fine, right? And if you want to finally conclude, like whatever I taught you or whatever you learned, is it trustworthy, or you can rely upon what I taught you till now? So for that, I have a document here. So you can make sure yourself that what I taught you and what you learn is correct, is the way you need to learn the pharmacoepidemiology. Okay. So for that, I brought you here the FDA approved a new indication for empagliflozin documentation, and I'll give you some points here. So the first point from this document, what I have taken here, it is one of the first anti-diabetic medication, empagliflozin, to be approved to reduce the risk of cardiovascular death. So it is already having the indication of type 2 diabetes mellitus, but because of this article, whatever I have given to you here, NEJM article, because of this article, because of this research, the FDA gave one more indication for this empagliflozin, that is to reduce the risk of cardiovascular death among the people who are having the type 2 diabetes mellitus and the coexisting cardiovascular diseases. Okay, and this is the only one and the first medication to receive that indication from the FDA because of this particular research. And what they've given here, you can see empagliflozin reduces primary composite outcome, that is cardiovascular death, non-fatal myocardial infarction, and the non-fatal stroke by 14% in patients with the type 2 diabetes mellitus and known cardiovascular diseases. So what are the 14% we understood from that table? It is fine. It is correct because it is mentioned in the FDA document. And there's a 38% reduction in the CV mortality, right? That's what we got to know. Forget about this one. So we got to know that there's 38% reduction in the cardiovascular mortality when the people are receiving the empagliflozin, right? That's also correct. And also we have seen empagliflozin added to standard therapy, which is preventing 32% reduction in the risk of death from any cause. So death from any cause, how much percentage we got? It is around 32%, right? So we got to know that what are the percentages we got in the previous table, whatever we understood, whatever we interpreted, the results, everything is fine. I taught you correctly. Okay, so you are having a confidence now how to interpret all the results, and it found to be same. And this one is a prescribing information for that Jardiance. Jardiance is a brand name for the empagliflozin, and you can see here initially the empagliflozin having only this indication. It is an adjunct to diet and exercise to improve the glycemic control in adults with a type 2 diabetes mellitus. And in 2016, they have added one more indication based on the research what I explained to you, to reduce the risk of cardiovascular death in adult patients with the type 2 diabetes mellitus and established cardiovascular diseases. So this is an indication they have added newly, new indication added for empagliflozin after this particular research what I explained to you. Okay, so that's one of the major come back to that medication, so that the sales of medication can be increased because of the indication. And from the previous class and today's class, hope you learned all these things like we have discussed about various study designs, cohort study, case control study, cross-sectional study, and randomized control trial. And also we have discussed about various outcomes. We are going to be calculating the prevalence, the percentage when we conduct the cross-sectional study, and we are going to be calculating the incidence proportion and the incidence rate for the cohort study. And from the incidence proportion, you're going to be calculating the relative risk. And from the incidence rate, you're going to be calculating the hazard ratio. And whenever you conduct any case control study, the retrospective study, you're going to be calculating the odds ratio, right? So these are all the things we learned from the pharmacoepidemiology and very important components of pharmacoepidemiology. So once you know all these things, you can surely say that I know some pharmacoepidemiology. Once you know about the study designs, some of the outcome measures, and from these outcome measures, what are the risk measures you are going to be calculate and how you're going to be calculate, what is the formula, and once you get the values, how to interpret all these values. If you know that much, it is more than sufficient for you being a graduate student. And this is what the textbook I'll recommend to you to go through further about the pharmacoepidemiology. If you want to understand more about pharmacoepidemiology, one of the standard textbook we are having is a Brian-Strom. I think latest version is available currently. It is a 5th one. I think current one is a 6th or 7th one on pharmacoepidemiology. One of the standard book which is there in the pharmacoepidemiology. There are many other books, but this one I felt more standard one, written by the Brian-Strom, one of the pioneer in pharmacoepidemiology. We can say usually he's a father of pharmacoepidemiology. And apart from this textbook, some of the easy concepts, whatever I explained to you, how to interpret all the results, how to calculate all the odds ratio, relative risk, hazard ratio, all the things you can get from any other online sources. And one source maybe I can recommend to you is online courses from the Pennsylvania University from this website. I found that they have given a clear document on all these calculations, all the study designs, so you can understand very clearly. So further, if you want to go through on all these things, you can even go to this link and then understand further. So that's it from my end. Thank you very much for your attention. Maybe we can stop it here. If you have any questions, maybe we can discuss further.